Hold on. A few years ago, a computer program called AlphaGo played Go, the oldest board game still widely played, against one of the best humans on Earth, Lee Sedol. Many experts thought computers were years away from winning such a game because of its enormous complexity. To be honest, the computer actually shocked the world. If you like Roblox, Minecraft, Clash Royales, like many other middle schoolers, imagine your game getting so smart it surprises even the pros. Today, I'll show you how computers learn to play and win. And while that same kind of science and learning is actually helping in many fields like health, technology, etc. So, why was Go such a huge challenge? Go is very hard. You can see by the horizontal and vertical indexes, uh, letters A through T, and then 1 through 19, that there and the different tiles, which are black and white, there is enormous complexity in the game. It may look simple, black and white stones on a grid, but it explodes with possibilities after every move. For example, to compare in chess, you might have around a dozen or so legal moves. In Go, you can have hundreds mid-game. That means that if a computer tries to look ahead at every possible future board, it gets overwhelmed super fast. Researchers said Go was the Mount Everest of board games because of one, its massive branching factor, too many possible moves, which continually and exponentially expand after every move. And two, it's very hard for a computer to evaluate who's winning at any moment just by counting pieces. As you can see, there are many different pieces on the board, but the thing is, the vertical and horizontal parameters make it where there's so many different combinations for the value of each piece relative to the board. Computer game researchers like Julian Toligas point out that Go offers hundreds of legal moves per turn. That's way more than chess. So searching every possibility is almost impossible. This problem stumped programs for decades, even after computers beat humans at chess. Early AI papers and a 2016 Nature study, which I will reference throughout this presentation, by Silver and colleagues, called Go search space enormous, and admits past programs were stuck. So, if brute force wasn't enough, how could a computer learn its way up this enormous mountain? Introduction to reinforcement learning, the technique that AlphaGo used. So, reinforcement learning, otherwise known as RL for short, lets the computer learn from experience. Think about training a puppy. A puppy sits, you give it a treat. The puppy barks, you don't give it a treat. Over time, the puppy figures out what works and how to maximize its treats. Similarly, an RL, the agent, which is a computer, takes on an action, such as placing a stone in a Go, and in the environment, which is the board and opponent, responds. Then the agent gets a reward, win, lose, number of points. Then it updates its internal brain to try better next time, and it keeps doing this until it maximizes the game. It's kind of like in a video game, you keep grinding and you level up and you get more and more XP based on your moves, and you naturally do better and gain XP more efficiently. So you repeat, except in this case, you repeat this loop millions and millions of times as the agent improves. Even the special thing is the agent doesn't even have to start up smart. It just keeps getting better and better. So in the textbook Reinforcement Learning, Sutton and Barto explain that an agent learns by taking actions, seeing results, and updating based on rewards, kind of like that puppy treat example. So on this slide, you can see something similar. The agents can move by setting a force on themselves in X and Y directions and rotate it along the Z-axis. And they can see objects in their focal view, and they can sense distance on objects, walls, and other agents. And so the stuff in the third picture and third panel wasn't just magically there. The AI actually trained itself to perceive these things through continuous training. So it's pretty cool. And here's another little uh, loop for how that works. So the agent gives an reward model and predicted reward, and then the RL agent then gives action to environment, and then the environment basically judges how good the action is and feeds it back to the RL agent. And then this loop continues cycles. So let's talk about how AlphaGo use RL. But AlphaGo use RL, but also another cool idea called deep neural networks. So this is how AlphaGo learn. In March 2016, AlphaGo played a best of five match against the world champion Lee Sedol in Seoul. AlphaGo won four games. Lee won one. The whole world watched online. A Wired report on the 2016 AlphaGo Lee Sedol match highlighted two famous plays. So here are the plays right here. Move 37 and move 38. So AlphaGo's unexpected move 37 in game two, and Lee Sedol's brilliant move in move 78 in game four the one game a human won decided a course of both matches. The match gave us two legendary moments. Move 37 is in game two. AlphaGo played a move that no human ever expected until it helped win. It was a very counterintuitive move, but it basically turned the entire game. So that clearly shows the advantage AI can have over our brains. And then human brilliance is also very exceptional and still isn't just magically overshadowed. Because in game four, Lisa played a brilliant game, brilliant wedge that confused AlphaGo so much that its previous training data rendered it helpless, and Lee won this game. However, he only won one out of four games, showing that there's a clear difference in the capabilities of both. So these surprises show that both machines and humans can be creative, that we can push each other to get better. So I know this is just a board game. Maybe it's not that practical in real life. There's a lot of other applications for AI as well, in many important fields, like I mentioned earlier. So let's take a look at some of these examples. Why does this matter to you? Same learning ideas behind AlphaGo now help solve real-world problems. Imagine delivery routes that learn traffic patterns to get your packages faster. Health systems, uh, trading models to pick better treatment plans, energy grids, learning when to store solar power. Even the games you play use similar learning to match players or make smarter non-player characters, kind of like NPCs in, modern games like Genshin Impact, Minecraft, etc. Lee couldn't be and go, and Hinton wrote in this Nature article in 2015. Yeah, deep learning systems use many stack layers to find patterns in data, exactly the kind of pattern power AlphaGo uses to recognize strong Go positions, similar to the many real-world examples. If a computer can learn Go strategy from practice and feedback, it can also learn safer driving rules, better study schedules, or how to make robots help in a disaster. Kind of like this little GIF I've shown you here. Here's a robot that uses reinforcement learning and doesn't use it, and how it's very clumsy in the beginning and kind of fumbles, almost falls over. But with reinforcement learning, it can smoothly go over these obstacles. So it's kind of cool how you can see the tangible impact that reinforcement learning has and how artificial intelligence keeps getting better and better by the day. So that's why learning a bit of coding and data now could help you build the next breakthrough. So let's wrap up. Here are some of the core ideas we reviewed. Some problems look impossible, just like Go once did. Problems can be unfathomably complex. With practice and feedback, computers and people can get better. So that's pretty cool how we can synergize with computers like Lee did in that match. So, for example, in that final game, Lee made a very brilliant, unexpected move, which AlphaGo has not seen before. But if AlphaGo were to play again, it would play even better because it has now trained based on that move. So we can improve hand in hand and synchronize with AI. And when we combine human creativity and machine learning, we can unlock new and novel solutions, which are brilliant for the humanity and future of mankind. So, what will you teach a computer to do? If you try this, ask your teacher about coding clubs or AI projects. Look at some GitHub tutorials. There's a lot of resources on YouTube. And if you have any questions, let me know.